Number 4, 5 and 6. Now we have problems that sort of look like the previous ones, but they have e's in them, right?
Yeah.
And if they have the base e, we have to do the inverse of base e, which is natural log instead of log. So our first step is going to be take the natural log of both sides. So I'm going to write it as ln of e to the x power equals ln of 6. Whoops, what am I writing there? 6. So taking the natural log of both sides, I can now do what I did before, take my exponent and move it out in front. So this one has just a plain x. I don't really need the parentheses, but if you want to put the parentheses there like we did before, we can. So natural log of e equals the natural log of 6.
So all ln if it's natural.
It's backwards.
Oh, okay.
The n is for the natural and the l is for the log, and I don't know why they write it backwards.
Okay.
But ln is for natural log. I suppose they use log and natural, who knows. Now, the natural log of e is equal to a certain value. So we're going to take our calculator and figure out what that is, because we're going to have that a lot when we work with this. Because they're inverses of each other, they undo each other, but we're going to calculate what is the natural log of e. So on your calculator, you have that little button that says ln, right? It's way over on the edge. We're going to do that. And then behind that, we have to do the e. So we are going to do shift and the ln button. Now the weird thing on here is you have to put a power behind the e. The e is to the first power, and so in parentheses you're going to have to put a 1 behind there. So on your calculator you're going to see ln, e, and then you're going to put a 1 just in parentheses. Yep.
Okay.
To say it's e to the first power. Okay, so if you hit equal there, what do you get?
1.
You get 1. Because the natural log and the e are inverses. They cancel each other out. Every time you have the natural log of e, you're always going to be able to replace it with a 1. So that's a new rule that you'll want to remember, because it's kind of a pain to calculate it with your calculator. You might want to have to do that every time. So we now know that the natural log of e is equal to 1. So this is going to be x times 1 equals the natural log of 6, right? And x times 1 just going to give me x. So x is equal to the natural log of 6. Now it tells us that, again, when we solve for our variable, we want to round our answer to the nearest hundredth, which tells me I'm going to use my calculator and figure out what the natural log of 6 is. Now the natural log of 6 is easier to do. You just have to put natural log and put the 6 behind it. So if you do natural log of 6, what do you get on your calculator?
1.79.
1.7917, which rounds off to 1.79, right? Because we're rounding to the nearest hundredth. So 1.79 would then be our answer. All right, so number 5, looking at number 4, thinking about what we did. Since it has a base of e, what should we do with both sides?
Okay, we have to put ln.
The natural log of e to the 9y power equals,
9y power equals 7.
not 7, but
ln.
the natural log of 7, yep.
Log of 7.
Okay, then what did we do with that?
And then we go 9e.
9y.
9y.
So 9y is going to go in front,
Yeah.
because our exponent can now be moved to the front.
9.
So 9y times the natural log of e equals the natural log of 7. Then what did we do?
then we did 9 times 1,
9y times 1, and why did we put the 1 there?
because that's 1 is an E, yeah.
Yep, the natural log of e is equal to 1, so we replace that with 1 equals the natural log of 7. So now we're going to have 9y equals the natural log of 7. Well, on this one, we've got one more step that we have to do, because on the other one, we just had a plain x, but this one we have a 9y. So what do we have to do with our 9 yet?
Divide.
Divide by our 9. And again, since we're going to use our calculator, I'm just going to write it with a division sign instead of as a fraction. Natural log of 7 divided by 9. And so we're going to figure that out. Natural log of 7 divided by 9.
0.2162, is that what you got?
Yep, that's what I got. So if I round it to the nearest hundredth, I would say
0.22.
exactly 0.22. So number 6, same kind of thing, just a little different because now we have an adding in there instead of a multiplying, but we'll figure that out at the end. What should we do first?
Natural log.
Natural log. Natural log of e.
Y plus 6 equals 12.
Natural log.
Natural log.
If I do it to one side, I got to do it to the other side, right?
Yeah.
So I'm going to take the natural log of both sides since I have that base e, and then I'm going to
You're going to go y plus 6 times the natural log of e equals natural log of 7.
equals the natural log of what?
7.
Nope. 7's not even in our problem.
Oh, where did I get 7?
From the previous one.
12.
12. So all we did is move our exponent out in front.
So then we go how are we going to do that now?
What are we going to do next?
Oh, so we're going to go 6y.
We're going to do y plus 6. We're not changing that.
Okay. So
All we're going to do here on this step is replace the natural log of e, right?
yeah,
So
times
y
1.
plus 6 times 1 equals the natural log of 12, because the natural log of e is 1. And if I take y plus 6 times 1, what do I get?
1.
If I take y plus 6
Oh,
times
6.
1,
You're gonna get same thing.
I get y plus 6, right?
Yeah.
I don't really need the times 1. Anything times 1 just gives me the same thing, right?
Yeah.
I still need to solve that for y, so this time what do I do with my 6?
You're going to move it.
By?
Minus.
Minus,
Negative.
exactly. I'm going to subtract my 6. Good. So y is going to equal the natural log of 12 minus 6 on this problem. So natural log of 6 minus, or natural log of 12, I'm trying to do the wrong problem. Natural log of 12 minus 6.
So that's going to be negative.
Negative.
3.5150.
So if I round it to the nearest hundredth,
It's going to be negative 3.52.
exactly. All right. So if we just have plain numbers, we do the log of both sides. If we have an e, we do the natural log of both sides.